This is a presentation of Chapter 4, Section 4 in the 8th grade workbook, Scientific Notation. So let's go ahead and take a look at the top set of questions out there. There's some very specific types of questions there, two very specific types of questions. We have questions with positive exponents and we have questions with negative exponents. And each gets approached a little bit differently here. When they're asking us to write the number in standard notation, they mean they want us to write the question just as a regular old number, like what we see in 13 to 24. So remember, scientific notation always starts off with something written between 1 and 10. And as you can see in all these questions, the first part in the multiplication question, they're all something that's between 1 and 10. So these all fit the mold. And then the second part is always going to be times 10. And then we've got the exponent. And again, that's what varies from question to question here. When we have a positive exponent tells me how many place values I need to move the decimal to the right to come up with the number in standard notation. So in number 1, where the exponent is a 2, that means I'm going to move the decimal 2 places to the right. And when I move the decimal 2 places to the right, I come up with 254. And that's all I have to do. We can do that again in number 9. 8.59 times 10 to the 5th. Since the exponent is 5, to come up with the number in standard notation, I'm going to move the decimal 5 times to the right. Now, as you can see, what's different about question 9 is those last 3 jumps were all empty jumps. Empty jumps in scientific notation always fill in with zeros. So I'm going to add 3 zeros there to fill in those empty jumps there. And when I do that, I get 859,000, or commonly known as 859,000. And you can use that same approach in answering questions like 3 and 6 and 7 and 10. Now, what's different with negative exponents is when we have negative exponents in this form, instead of moving the decimal to the right, we move the decimal to the left. So that's what we're going to do there instead. So if we take a look at number 2, 6.7 times 10 to the negative second, instead of moving the decimal to the right 2 places, I'm going to move it to the left 2 places. So I'm going to jump 2 places to the left there. And as you can see, that second jump, again, works out to be an empty jump. Even though this is negative, not positive, that rule still fits. Empty jumps are going to fill in with zeros there. So that's going to fill in that front empty jump there with a 0, and we're going to end up with 0.067. Let's try this again in number 5, 7.53 times 10 to the negative third. So since the exponent here says negative 3, that means I'm going to make 3 jumps to the left. And as you can see, these 2 jumps that are in front were empty. So those are going to fill in with zeros. So this is 0.00753. And again, you can use that same approach with the negative exponents in questions like 4 and 8 and 11 and 12. All right, let's go ahead and go down to the second part there, where we're asked to write the number in scientific notation. So now we're going the opposite direction of what we just did. A minute ago we started with scientific notation, we wrote it as a number. Now we're starting with a number and we're supposed to write that in scientific notation. So the directions for doing that, as you were instructed today, was to start off and write this as something that's between 1 and 10, which means you insert the decimal in there somewhere between the first 2 non-zero numbers to make that happen. So in 75 million in number 13, I'm going to drop the decimal between the 7 and the 5. And when I do that, I end up with 7.5. And then it's always times 10. And then what we have to figure out is what's the exponent going to be to make that happen. The exponent, again, is the number of times we move the decimal to make that happen. So we now know that the decimal is between the 7 and the 5. What we have to figure out is how many times I would have then moved it to get it there. Well, when we started this question, it was out here after the last 0. So that's 1, 2, 3, 4, 5, 6, 7 jumps to the left, so the exponent is going to be a 7. And you'll use that same approach in answering questions 14, 15, and 16, and then down towards the bottom in 22 and 24. Now what's probably more complicated or more thought-provoking for us is a question like 17, 18, 19, 20, and 21. In those questions there, we're going to have a negative exponent, as we know from looking at the top, because these are starting off as decimals. So if we take a look at a question like 17, we're going to drop the decimal between the 9 and the 3, because that's how we're going to get something between 1 and 10. So that's going to give me 9.3, and then it's always times 10, but the exponent here is different. Because I had to move the exponent to the right, from the left to the right, to get to that placement, the exponent is now going to be negative. So since I would have had to move it 2 jumps to the right to get there, the exponent is going to be negative 2. Let's try that one more time in question number 18. Question 18, we've got 0.000006, 4 zeros and a 6. So what we want to do is drop that decimal after the 6. Now you might be saying, well, wait a minute, there's not another number there. You're right, there is not another number there. But of course, if I wrote 6 point, that would be the same as the number 6. So that's going to be spot on with what I need, because remember, that first number has to be something that's between 1 and 10. Then it's always times 10, and then there's an exponent. The exponent is how many times we move the decimal to make this happen. So in doing this, we would move 1, 2, 3, 4, 5 times to the right. So the exponent is going to be negative 5, and we end up with 6 times 10 to the negative 5th. And again, you can use that same approach in 19, 20, 21, and 23. Put it after the first number that's not a 0. Generally, that's going to be in between 2 non-zeros right away. 20 and 21 are a little bit odd in that there's a 0 after the first number, but it will still work out fine. Put it after the first number that's not 0, and it'll work out great. All right, let's go ahead and take a look at the story problems to finish up this presentation. We'll go ahead and take a look at number 26. Number 26 says the E. coli bacterium is about 5 times 10 to the negative 7th meters wide. A hair is about 1.7 times 10 to the negative 5th meters wide. Which is wider, the bacterium or the hair? Now this question would probably be really easy if it was positive exponents, but it's not really that easy because it's negative exponents. What you have to remember here is that that exponent is going to indicate how many times, because it's negative, how many times I'm going to move the decimal to the left. I don't need to actually rewrite these because I can figure this out in my head. If I'm moving this 7 times to the left, that's going to give me a long decimal. If I move this one here only 5 times to the left, that's going to give me a shorter decimal. Well, think about it. In decimals, the shorter the decimal, the bigger the number there. So the shorter decimal is going to then be, of course, the bigger number, or in this question, the wider number will represent the wider thing. So in this case, the hair here is going to be wider at 1.7 times 10 to the negative 5th meters, because it's going to generate a shorter decimal. And that's going to be our answer.